Hey everybody, today we'll do another video, and today we'll do another. It's going to be a math problem. It's going to be in the area of differential equations. It's going to be an initial value problem. So basically, what it says is, it says in problem 20. 25 to 36, solve the given solve to 36, solve the given initial, I don't know if this is working, but this is okay. So the given initial these markers are not cooperating actually. Okay. Alright, solve the given. This is working better, I think. So solve the given initial value problem. Okay, so right, and it says give the largest interval I over the solution. The interval I, right? So interval I over the solution, right? Over the solution. Solution defined, right? Defined. Right, so that is the problem statement, right? So they over in which, okay. Over which the solution is defined. All right, so okay, so they are asking to give the largest. I mean, that problem is going to be the easiest part of it. So the problem we're doing is, it says dy, which is number 25 actually. In this book that I have, right? So if you have this book, you can follow, right? So basically the problem is dy over dx equal to x plus 5y, right? And of course a keyword right here, it says initial, right? Initial value problem, which means that a value like this has been given to us as 0 is equal to 3, right? So after we find the differential equation and we find a solution, we given a specific point where the value of the where this value, this y function depends on some x value, and if this is the dependent variable and depends on x, then the value of that function is going to be 3, right? It's going to be a solution somewhere, right? We don't know where, but it's going to be a solution. So, okay, so let's do this. Okay, so first of all, we need to see what we can do here, right? So basically, we have a derivative, and then we can check, right? How can we solve it, right? If I try to separate this, will be separable. Actually, no, it will not be separable because I will have something like this. So let's say, right? So I try to move the y on this side and the x on this side. Well, if I move the y on this side, it's going to be dy dx minus 5y, right? dy dx, if I subtract 5y, right, is going to be minus 5y is equal to x, right? Now, is this separable? The question is this separable? No, because I cannot separate these two guys right here because I will have something in between, right? Because in order for me to make this separable, this has to be kind of complete unit. And right here, if I multiply this times this, I cannot just multiply this and this. I have to take care of this. When I multiply by dx, this is going to be a dx, and then a dx is going to be mixed with y, so it's not separable. Okay, so now we look in other methods, right? So we know that is not working, right? Separation of variables. Now, we will look at something else, right? So now in this case, we have something right here, right? So let me erase that and erase this, right? So now we have another tool. That this tool is called something. That this tool is it is called integrating factor. Okay, so the integrating factor says that if I have a function, right, that is in the form of something, dy dx plus something, so okay, so let's see, dy over dx, right, plus something, right, plus a function of p of x multiply some variable of y, right, is equal to f of x, right? So it's equal to another function on the other side. In turn, this piece right here itself is equal to another function in the other side, right? So in the case of this, we need to look at something that can be taken the integral, right, that has a derivative with respect to x, right? And we have an x over here or an x over here. We have a single y over here that is hanging, right? But then we can think about this as the coefficient, right, of y, right? Make it sure that we understand that. It's a coefficient of y, right? The p of x is a coefficient of y. Okay, so now let's think about this. Okay, so, but in order to make it a standard form, it gotta be in this, right? It gotta be in this form. Is this in the right form now? No, it's not, right? And the reason why it's not is because you can see that I have something, I got a dy dx by itself here. I don't have anything related with with p of x multiplying y. Now, if I do what I did before, right? So I do dy over dx, subtract phi y, right? And this, if I subtract phi y, this becomes phi y, right, equal x. Now, if you think about it, this right here is a coefficient of 1 right there, right? We don't see it, but it's there, right? Think about that for a minute, right? We don't write it, but it's there. Okay. Just to kind of help us out a little bit. In other words, this is the value of this guy, all right? So this is a function of x. Now, this problem looks easy, but it's not quite too easy. It requires a little techniques that we learn in mathematics, how to solve problems. Now, if I do, we call it integrating factor of r of x is equal to e to the integral of p of x, right? So we taking the integral of the coefficient of y. Okay, so but we taking the e and we taking the e base as a base, but we actually taking the integral of this power, right? Okay, so we integrated the p of x with respect to x. Now, if you think about it, now we know that this guy right here is a coefficient, and you can see that this guy right here is a coefficient, right? It's a coefficient of y. You can see it. You can see it right here. It's a coefficient of this y. Now I will have to find what is called the integrating. This guy right here is called integrating factor. I have to find some integrating factor called r in order to try to make this to work. Okay, so let's see how that works. Okay, let's see if this can work. Okay, so now I will take r, r of x is equal to e to this integral of 5, right? I'm taking just the coefficient and I have a dx in there. But remember, this is negative, right? So negative 5. Now, when I integrate this, I get the r is equal to what? So r of x is equal to what? Is equal to e integral of, okay, so e raised to this integral, but I'm taking the integral of that. So technically this is 5x, right? Why 5x? Because it's dx. dx becomes 5x, right? And you will think, okay, if you're taking this definite integral, you need a plus c right here. Not necessarily, because we're only looking for integrated factor. We don't care about the constants right now. Okay? So basically we just leave it like that. Leave it as it is. Okay, now, so this is the problem statement, so let me just raise it. Now we have something like this, right? So we have e, so this is the integrating factor now. That is the integrating factor. Now that I have the integrating factor, right? I need to take this integrating factor and multiply the function that was put into standard form by the integrating factor. Okay, So now, what is the function that we have in the standard form? This right here, right? So this is the function in the standard form. Standard form. So this is the function in standard form. So I'm going to take this guy and multiply this by that, right? In order to see what I get, right? So we take the integrating factor and multiply the function that is in the standard form. Okay, so we take dy, right, over dx, and then we multiply this guy by e to the minus 5x. Okay? Now, if you think about it, think about this for a minute. We already did this. We already did this, right? We took care of the 5. We did not take care of the y. But we already take care of the 5. So what we can do is just write y, right? Because we already took care of the 5. We took the integrating factor, right? We write a y here. And then that guy is equal to what? It's equal to, if I multiply the left by e, then I have to multiply the right side by e to the 5x, the same thing. So now we have an x. This x right here is multiplying by e to the negative 5x. Okay, when I do that, notice that right here, what I can do, I can factor out, and I can think about this, that this y is being just dropped, right? So this y can be just dropped down, and when I do that, so the way that is because this y, remember, we were taking the derivative with respect to x, right? But y is a dependent variable. Think about that, right? So now what we can do is just drop this y and just leave it at y. I can think about factoring that y out. Now, when we do that, right? So we need to integrate this. Now we integrating both sides of this, right? Integrating both sides. When we integrate this, these guys get dropped, right? This guy get dropped, and we only get this and this. So we get e to the 5x y, right? And it's equal to the integral of x e to the minus 5x. Okay, so now, that's what I said. I say that this problem look easy, but it's not too easy. If you look at this side right here, you know that it's going to be a process how to get the integral of this guy. This guy, I did not take the integral of this guy yet. So that is the integral right there. And of course, this is going to be a dx. Okay, so now we have this, right? So we integrated the left side, but we need to do the right side. Okay, so now we take that. And we said, okay, so 5, so we have e to the negative 5x, and then multiplying that y, right? Now look at this. So we have an x e to the minus 5x. Now Look at this guy. This is not easy integration by itself. It requires some techniques over here, right? So basically we say that we will look for something, right? Think about this like this function. There is two functions. One is this and the other one is this, right? e to the minus 5x is one function and x by itself is another function. So let's do which one is the easiest function, right? The easiest function is x. So we let u is equal to x, right? And then we say du is equal to dx. In other words, we are here, we are integrating by parts. Integrated by parts. Okay, so we have this. Right? Now, what else we have? We have, so remember that the formula for u, for integrated by part is v, right? So, v du, no. Is u, right? U times v minus the integral of v du, right? So notice that I have a u is equal to x, du is equal to dx. Now I need to find v, right? V, right? So now, in order to find v, right? So in order to find v, I need to say that dv is equal to dv is equal to v, right? So which one is my v? This is my v. So dv is equal to e to the minus 5x. So integrate both sides, right, in this guy, and I get that v is equal to 1 over 5 e to the minus x. Okay, now we have something. So now what I can do is, now that I have my v, now that I have my v, right? So now that I have my v, is going to be the following. So so now that I have my v, right? Okay, so now that I have my v, I can actually, what I can do is simply say, okay, so now I have my v. So now what I can do is the following. So I can write it like this, right? So now I have this v, okay? So now I can say, okay, minus 1/5 e to the negative x, right? Parentheses, because technically this, I can write this, I will simplify it. So now I am in, okay, so now I do this, right? So Now I do the following. So now I do what? So V du, right? So V du is right here, right? But what is V? V is this guy, right? So and what is du? What is du? Du is equal to dx, right? So what I can do is the following, right? So what I can do is the following. So I can put my 1/5 right here, negative e to the minus x, and because du is equal to dx, I can write dx, right? Now look at this. If you look at this, right? So now this guy, it's right here, it's already done, right? So all I gotta do is pull this negative sign in front, and I can say negative x, right? Negative x, 1/5 e to the minus x, right? And right here, right? As you can see right here that this becomes a plus, right? Because this is negative, this becomes a plus. The integral of 1/5 e to the minus x dx. Okay, but I just changed the sign. I need to integrate this, right? So I need to integrate this. When I integrate this, I get minus x multiplying 5 e to the minus 5x, right? If I bring this to the front, right, to the bottom, right, to the bottom, so I am integrating this. So when I'm integrating this, I get 1, right? I get this drop down, which becomes what? Becomes 1/5 multiplying by negative 1/5 e to the minus 5x, right? And it's a dx, right? And I can say that in this side I can get a c, right? Look at this. Now this guy becomes a negative because I am dividing. This is going to be negative 25. And negative 25 is part of that 1. So that sign is going to change. So now x is going to be negative x over 1/5 e to the minus x minus 1/25 e to the minus x plus a constant, right? So now this is part of the problem, right? So now we actually found the left side, right? Now we have this side, we have this guy now figured out, right? Now what I can do is kind of work it out over here. Maybe kind of do a line that way it doesn't create too much confusion, right? So now I can put this guy in the left side and this guy in the right side. Remember, this is the right side, right? So I get e the minus x times y, right? Equal to what? Equal to that guy, which is negative x over 1/5 e to the 5x, right? Minus 1, oops, minus 1, right? Minus 1/25 e the minus x, right? Plus c, right? Plus a constant, right? Now, look that I have e in both sides, right? I have an e in both sides. So what I can do is divide by e to the fifth. Divide by e to the fifth. The negative x, right? Divided by e to the negative x. Divided by e to the negative x. And divided by e to the negative x. Okay, so now when we do all this, right? Now think about flipping this, right? We're dividing this fraction, but this guy is getting flipped. So y is equal to negative x 1/5. 1/5, right? And because this guy is over 1, that guy is over 1, that guy is over 1, it's kind of getting flipped. So now this guy is e to the minus 5x, and also this guy is e to the minus 5x, right? Kind of getting messy right there, but it is what it is. Sorry. So e to the minus 5x minus 1/25 e to the minus 5x over, so this is e to the minus 5x plus e. Okay, so now the same thing here. When I flip this, that kind of, in this case, it just flipped. So this becomes a multiplication thing. So it becomes c to the e minus 5x. Okay, so this guy cancels with that one, right? That cancels. That cancels. Okay, the only one doesn't cancel is that one. Right. So now we have what? We have y equal to negative x over 5 minus 1/25 minus 1/25 yes, minus 1/25 plus minus 1/25 plus what? Plus c to the minus x. Right. So this technically is what is called a general solution. It's pretty close, right? This will be a general solution, but they are not asking for a general solution. What they want the initial value problem, right? Because we have a value that was given to us that, I think I erased it, but the problem was that at this point at y of 0, it was equal to 3. Okay, so that is initial value problem, right? Now, the initial value problem was given to us that at y of, when x equals 0, y is equal to 3. Okay, so now what we can do is that we can actually replace this guy by y, right? This, we can replace this 3 and substitute it into y, right? And then the value of x, whatever we see an x, we will put a 0. Okay, so whenever we see an x, we will put a 0. Whenever we see a y, we will have to put a 3. So in this case, it's 3, right? Now, 0 over 5 plus, minus 1/25 plus e to the negative 5 times 0 to the negative, to the negative 5 e to the 5th, right? Negative 5th, right? But it's negative 5th x, but x is equal to 0, which means that this is just, okay, so that is multiplying c, right? So this guy is equal to 1. Okay, that's this guy is equal to 1, right? That is 1. If this is 1, then I got 3, which is equal, and then 0 divided by 5 is 0, so minus 1 25th plus z. Plus c, right? Why? Because that is 1, right? So this guy is 1, so this e right here, okay, the whole thing is 1, right? So this is 1, so if that is 1, the whole thing e is 1, so now I have a c, right? Now we want to solve we need to solve for c, right? We need to find the value of c. Now, so we have a 3, right? So we have 125, 1 over 25 negative plus c. Okay, so we want to solve for c, so we say that 3 plus 1 25th is equal to c, right? Find the common denominator of this, which is find the common denominator of this. This is over 1, so it's going to be 75 over 125, right? I guess I don't have to do this. I mean, this is basic math. I don't have to better do all this stuff. I mean, okay, so this is like 1, okay, so it's 75 over 25, you know, the common denominator, right, of this. So plus 125 is equal to c. Now we notice that the common denominator right now are the same. Now we say that c is equal to 76 over 25. Okay, so now we have the value of c, right? Now remember that we end up with this guy, right? So after we did all this was the kind of general solution, right? After we did all the bunch of, you know, yeah. So divided by e to the negative 5x, we got that was the general solution. So basically, we will substitute for c the value, this value right here. So the regular the solution for the differential equation will be y, right here. That will be y, right? And of course this guy. So but remember this guy right here, right? So it's going to be negative. This is negative. So it's going to be negative x over 5, right? And then minus 1/25 plus. See, look at this. I have a c in front of that e to the negative 5x. So I am replacing this guy into that. So it's going to be 76 over 25. 76 over 25 e to the minus 5x, right? Now, I mean, can you simplify this? Yes, we're not going to do any better, right? You can find the common denominator of this and, you know, multiply this by 5 and then multiply this guy by 25, right? But then if you divide by 25, then you will get 25 over here, right? If you find the common denominator over here, you will make 5, right? So 5 is going to be 5 right here, 25, right? 5 times 5 is 25, and it's going to be negative 5x on the top. So it's going to just create a bigger mess, and this is the best solution for the problem. Okay, so That's a been for today. About this little problem that we did. It seems like it's easy, but it's not too easy. It's one of those that requires a little bit of integration by parts and all that. And thank you for watching. I'll see you in the next video. And remember that this is, now we change the name of the channel. Now the name of the channel is Christian Engineering Academy, right? More straightforward, right? More straightforward. Why? Just be straightforward. Christian Engineering Academy, and remember, we believe that we learn over here in this channel because Jesus is good. And I see you in the next video.